Hello everyone, welcome to Principles of Operating Systems. I am Gomati, working as Associate Professor in Department of Information Technology. In this lecture, we are going to discuss about virtual memory concept. The contents that are going to be covered in this lecture are: what is demand paging, what is the benefit of valid or invalid bit in page table, what is page fault, and how it can be handled by the operating system. In this slide, we are going to discuss about the basics of virtual memory. Virtual memory mechanism creates the illusion that we are having large main memory. It means that we can run our application whose size is larger than main memory. How is it possible? While we execute our program needs to be transferred to main memory, but the processor does not require entire code or data at particular time. Hence, the required portion of program is alone transferred to main memory by using operating system with the help of virtual memory mechanism. Hence, this virtual memory mechanism allows to execute a process even that is not completely in main memory. So this technique reduces the burden of programmers by concentrating on the development of program instead of going to worry about the memory limitation. Based on the virtual memory concept, few pages of process is enough to start its execution at any instant of time. Later, when processor refers the remaining pages explicitly at the time, the operating system loads the referred pages in main memory. This technique is called as demand paging. The demand paging is utilized under virtual memory technique. Like paging concept, if memory is full, old process are swap out and new process is swapped in main memory under demand paging concept. In demand paging concept, one specialized service called lazy swapper that never swaps a page into memory unless that page will be required by processor. In demand paging concept, each process has page table that gives the details about where do the pages of process exist in main memory. Addition to that, page table maintains valid and invalid bit to identify whether the page resides in main memory or not. Here, the valid bit indicates that particular page of process is present in main memory. Then, the invalid bit helps to identify two different scenarios such that the requested page is currently not present in main memory. Another scenario is used to indicate that the particular page is not in memory because the address is illegal. In this diagram, it is clearly shows that how logical memory of process is divided into equal size of pages, and then the corresponding page table is given in this diagram. The page table gives the details about in which frame does the particular page is loaded in main memory. In addition to that, it has valid as well as invalid bit. If the page of particular process resides in main memory, it is represented with valid bit. Otherwise, it is represented with invalid bit. Now we discuss about the page fault. Page fault occurs when the processor tries to access any page which is not present in memory. Here the page fault is handled by operating system using the following steps. When processor tries to execute an instruction, then the corresponding page should be in main memory. Hence, the operating system checks the relevant page in page table. If the bit of the reference page is invalid, then the page fault occurs. Here, a trap signal is sent to operating system to inform about the page fault. Then, the OS checks for the required page is in secondary memory. Here, the memory frame location is identified using frame replacement algorithm. Later, the page table is updated with particular frame number and make an invalid bit to valid bit once the particular page is loaded into main memory. Then it is informed to processor. Processor restarts the instruction. So, in this lecture, we covered what is virtual memory, how the demand paging concept is utilized to implement virtual memory mechanism, and then we have seen page table entries. At last, we have discussed about what is page fault, how it is handled by operating system. Hope you all understood about virtual memory mechanism. Thank you for listening.